The MeterStick Optic set gives you a quality set of components without taking up much of your storage space. The MeterStick Optic set allows students to explore the properties of light and optics with observation, measurement, and analysis. It includes 2 convex lenses with focal lengths of 100 and 200 millimeters and a concave lens with a focal length of -150 millimeters. Each lens has a large built-in handle to prevent fingerprints when inserting into one of the 2 component holders. There is a large projection screen with a flat finished surface for accurate measurements. The bright green LED light source is easily visible in a well-lit classroom and comes with a charging cable. Everything attaches to a meter stick for accurate alignment and measurement. You can order the MeterStick Optic set with or without our famous aluminum meter stick. Experimental tools like the MeterStick Optic set empower students to answer their questions using easily obtained and accurate data. This enables them to construct and test models about the system they're investigating. For example, students can develop the thin lens equation as they collect image and object data while investigating image formation. So the light source just goes there on the end. Component holder, screen. Turn on the light source. And let's do one measurement. So I'm going to put this at 22. And so that is our object distance. The light source is the object distance to the lens. Then I'm going to move the screen until I get a nice focused image on the screen. And then I can easily measure the image distance, the distance from the screen to the lens. The light source is designed so that it lines up with the 0 mark of the meter stick. Each component holder is designed so that the lens is lined up directly over the indicator that can be easily seen from either side. The screen also has an easy-to-read position indicator. All these features allow students to take only a few minutes to collect a large set of object and image distances. SparkView and Pasco capstone software make it easy for students to analyze their data. After entering their measurements, they create a graph of image distance versus object distance. So these are my object distances. I started at 14 centimeters and added 4 centimeters for 7 points. And then these are the measured image distances, and I get a curve graphing image distance versus object distance, concave up. They can quickly manipulate their data to try and find a linear relationship. After some trial and error, they find the inverse of the image distance versus the inverse of the object distance yields a straight line. Might go something like this. This sure looks like an inverse, so let's graph versus the inverse of the objects. I created that calculation, rescale. Well, it got straighter. Maybe I need to try the inverse of the image distance as well. And there we go, bingo, a nice straight line. And just a click gives me a linear fit with the slope and the y-intercept. They developed the thin lens equation using the equation of their graph. They find that the slope is almost equal to -1, -1.01, and dimensionless. And the y-intercept has the same value in units as the inverse of the focal length, in this case about 0.1. They transform the equation of their graph into the thin lens equation. So I have that here. So they figure out this is the equation of their graph, y equals mx plus b, and they realize b is 1 over the focal length, and m, the slope, is -1, and then they can easily rearrange this into the more familiar form of the thin lens equation. Using their equation, they can predict and then measure image or object distances for the other convex lens. Student learning is maximal when they develop a model of the physical world with real data and then test it on a modified system. The MeterStick Optic Set is an effective and engaging tool for student model building in optics. More labs and activities for the MeterStick Optic Set can be found on the product page at pasco.com. Thanks for watching.